Hello everyone and welcome back to the channel. Today we're diving deep into a fundamental concept in any research project, sampling. How do you pick who to study? It sounds simple, but the method you choose can make or break your research. By the end of this video, you'll have a crystal clear understanding of the main sampling techniques and know exactly which one is right for your next project. Let's get started. Imagine you want to know the favorite pizza topping of every student at your university. Are you going to ask every single person? Probably not, it would take forever. Instead, you take a sample, a smaller group that represents the whole student body. The big question is, how do you pick that group? This is where sampling methods come in, and they're split into two main families, probability sampling and non-probability sampling. Let's start with the gold standard, probability sampling. The key idea here is that every single person in your target population has a known, non-zero chance of being selected. It's all about fairness and randomness, which allows you to generalize your findings to the entire population with confidence. The most straightforward type is called simple random sampling. Think of it like drawing names out of a hat. Every individual has an equal chance of being picked. You could use a random number generator to select students from a complete university roster, the big advantage. It's super easy to understand and gives you an unbiased sample. The challenge, however, is that you need a complete list of everyone in the population, which can be tough to get for large groups. Next up, we have stratified sampling. This is a bit more strategic. First, you divide your population into important subgroups or strata. For our university example, you might create strata based on year of study, freshmen, sophomores, juniors, and seniors. Then you perform a simple random sample within each of those groups. Why do this? It guarantees that you have proportional representation from every key subgroup. If freshmen make up 30% of the university, they'll make up 30% of your sample. This gives you much more precise results, but it does require more planning. Now let's talk about cluster sampling. This one is great for populations that are spread out geographically. Instead of sampling individuals, you start by sampling groups or clusters. For example, you could treat each dormitory on campus as a cluster. You'd randomly select a few dorms and then survey every single student living in those selected dorms. This method can save a ton of time and money, especially for large-scale surveys. The downside is that your results can be less precise if the clusters themselves are very different from one another. Finally, in the probability family, we have systematic sampling. This method is beautifully simple. You take your population list, decide on a sampling interval, let's say every 10th person, and then select every 10th name on the list. So you'd pick person number 10, number 20, number 30, and so on. To keep it random, you should always pick your starting point randomly, say starting with the 7th person, then the 17th, 27th, and so on. It's easy and efficient, but be careful. If your list has a hidden pattern, it could introduce bias. So to recap probability sampling, it's random, it allows you to generalize your findings, and it's the most rigorous approach. But it can also be expensive and time-consuming. Now, what if you can't do random sampling? Maybe you don't have a list of the population or you're short on time and money. That's where our second family comes in, non-probability sampling. Here, selection is not random. The researcher uses their judgment or convenience to select participants. This means you can't generalize your findings to the whole population, but these methods are incredibly useful for exploratory research. First, we have convenience sampling. This is exactly what it sounds like. You survey people who are easiest to reach. Standing outside the library and surveying the first 50 people who walk by is a classic example. It's fast, cheap, and easy, but the major drawback is that it's highly prone to bias. The people you survey might not be representative of the entire student body at all. It's great for a quick pilot test, but not for drawing firm conclusions. Next is quota sampling. This is the non-probability version of stratified sampling. You start by setting quotas for specific subgroups. For instance, you decide you need to survey 50 men and 50 women, but instead of selecting them randomly, you just find the first 50 men and 50 women you can, using convenience. It ensures you have representation from your key groups, but the non-random selection means you can't rule out hidden biases. Then there's judgment or purposive sampling. Here, the researcher uses their expert judgment to select participants who they believe will be the most informative for the study. If you want to understand the challenges of being a student athlete, you would purposefully seek out and interview student athletes, not just any random student. This is perfect for gaining deep insights from a specific group, but it's very subjective. Finally, let's talk about snowball sampling. This one is brilliant for finding hidden or hard to reach populations. Imagine you want to study urban explorers who secretly visit abandoned buildings. How do you find them? You might find one person, and after you interview them, you ask, "Do you know anyone else who does this that I could talk to?" They refer you to a couple of friends, and your sample snowballs from there. It's incredibly effective for niche groups, but your sample is limited to the social networks of your initial contacts. So, how do you choose? It all comes down to your research question, your resources, and your goals. Let's do a quick side-by-side comparison. For selection basis, probability sampling is random, while non-probability is subjective. In terms of generalizability, you can confidently generalize from a probability sample to the whole population. With a non-probability sample, you really can't. What about bias? Probability sampling is designed to minimize bias, whereas non-probability sampling has a much higher risk. And finally, for cost and complexity, probability methods are often more complex and expensive, while non-probability methods are generally simpler and cheaper. So if you're conducting a large-scale national survey to inform government policy, you absolutely need to use a probability sampling method. But if you're a student doing a small exploratory project to understand a niche subculture for a class paper, a non-probability method like snowball or purposive sampling would be a perfect fit. The key takeaway is this: there is no single best method. The best method is the one that logically fits your research goals. Choosing probability sampling when you need robust, generalizable data is crucial, and using non-probability sampling for quick, targeted insights in exploratory studies is a smart, practical choice. Understanding the strengths and weaknesses of each allows you to design better research and more critically evaluate the studies you read. I hope this overview has demystified the world of sampling for you. It's a topic that's so central to good research, and now you have the tools to make the right choice for your own work. What projects are you working on? Let me know in the comments below which sampling method you plan to use and why. Thank you so much for watching. If you found this video helpful, please give it a thumbs up and don't forget to subscribe and hit that notification bell so you don't miss our next video. See you in the next one.